In the last video, I talked about the meanings of the words abstraction and generalization. Now consider these sentences. We adopted a new pet this weekend. I ordered something I really wanted from the store. I bought a ticket and won a prize. If I said any of these things to a friend or co-worker, it might be frustrating for them. I haven't given them enough information in each of these cases. They can't visualize what I'm talking about because they lack details, which I didn't provide. New pet, something ordered, and a ticket are too general when talking about one item. On the other hand, when we talk about groups of things, we don't usually need too many specifics. Consider these sentences. I need to get home to feed the animals. I'm waiting for my box of stuff from an online store to be delivered. So here, animals and stuff are probably enough information to fully describe the situation. Before we get into when and where you'd use abstract classes, let's see what one looks like. The abstract class is declared with the abstract modifier. Here I declare an abstract class called animal. An abstract class is a class that's incomplete. For that reason, you can't create an instance of an abstract class. An abstract class can still have a constructor, which will be called by its subclasses during their construction. An abstract class's purpose is to define the behavior its subclasses are required to have, so it always participates in inheritance. For the examples on this slide, assume that animal is an abstract class. Classes extend abstract classes and can be concrete. Here, dog extends animal. Animal is abstract, but dog is concrete. A class that extends an abstract class can also be abstract itself, as I show with this next example. Mammal is declared abstract, and it extends animal, which is also abstract. And finally, an abstract class can extend a concrete class. Here we have best of breed, an abstract class extending dog, which is concrete. An abstract method is declared with the modifier abstract. You can see on this slide that we're declaring an abstract method called move with a void return type. It simply ends with a semicolon. It doesn't have a body, not even curly braces. Abstract methods can only be declared on an abstract class or interface. An abstract method tells the outside world that all animals will move in the example I show here. Any code that uses a subtype of animal knows it can call the move method, and the subtype will implement this method with this signature. This is also true for a concrete class and a concrete method that's overridden. You might be asking, what's the difference? And when would you use an abstract class? These are great questions, and I'll be answering them over the next couple of videos. In the videos on inheritance, we created a very basic animal class, and then we extended it to create a dog. This is the class diagram from that video again. In that example, animal was a concrete class, so the move and make noise methods had code in their method bodies. Subclasses have choices when they extend a concrete class with concrete methods. They can inherit the same behavior from their parent. This means they don't even have to declare the methods in their class bodies. They can override the behavior from their parent. This means they have a method with the same signature, but with their own code in there, ignoring the parent's code altogether. They can also override the behavior, but leverage the parent's method code by calling the parent's method using super in their overridden code. What happens if animal is declared as abstract, and the move and make noise methods are also abstract? If animal is abstract, and its methods are also abstract, subclasses no longer have the options I just talked about. There is no concrete method for a subclass to inherit code from. Instead, the subclass must provide a concrete method for any abstract method declared on its parent. The subclass won't compile if it doesn't implement the abstract methods. Why would this behavior be preferred to a concrete class? There may be times when it really doesn't make any sense at all for a base class to provide default behavior for a method. This mechanism forces designers of the subclasses to provide the implementation that's appropriate to the class they're designing. Now let's build this new version of our model. I've created a new project called Abstract Classes. I'll create a new class in that package called Animal. I'm going to add the abstract modifier in this case after the public access modifier. You don't have to declare the modifiers in this order, but it's common practice to have the access modifier be declared first. An abstract class can have inherited fields just like a concrete class, so I'll add 3. Type, size and weight. I've made type protected, but size and weight private. This means subclasses can access type directly without a getter method. I'll set up a constructor by having IntelliJ generate it using all three fields. I'll now set up the two methods on the diagram. This time though, I'm going to make those methods abstract. Public abstract void move with a string parameter called speed. Public abstract void make noise. Here I'm using abstract in the declaration of the methods, again after the public access modifier. After the method signature I end with a semicolon. We don't even specify an empty method body, meaning no set of curly braces. Actually, let's see what happens if I add curly braces. I'll add them to the first method, inserting them before the ending semicolon. You can see I've got an error there, and IntelliJ is telling us that abstract methods can't have bodies. Curly braces with no code in it is still viewed as a method body. It's an empty code block or empty method body, but it's still a method body, and abstract methods can't be declared with a method body. I'll undo that change. When you declare abstract methods, this means you don't provide any default behaviour for our subclasses. We're actually forcing subclasses to declare and implement these methods. Another thing you can't do is have an abstract method that's private. Let's try that next. That gives us a different error saying the use of abstract and private modifiers is an illegal combination. Can you understand why this combination would be illegal? When you use abstract, you're saying subclasses have to declare this method, but if it's private, the subclass wouldn't even see it. I will talk about these rules again, so don't worry if that's a bit confusing at this point. I'll revert that change so the animal class compiles "Let's create the dog class now" in the same package. And I'll add extends animal here, meaning dog inherits from animal, or in effect dog is an animal. There is an error when I attempt that. Hovering my mouse over the error, it's actually telling us this class must either be declared abstract or it needs to implement the abstract method moveInAnimal. Actually, there are two methods here that we need to implement, but this little error message is only popping up the first one. I'll click Implement Methods, and I'll select both methods there. That generates the methods with the same signatures as Animal's abstract methods, minus the abstract keyword, as well as empty code blocks. Notice I still have an error here, and maybe you'll remember why. Because I created a constructor in the animal class, a default no arguments constructor does not exist in that class. Because of that, I'm forced to create a constructor that will in turn call the explicit constructor I created in the animal class. I'll select the create constructor matching super option. I want you to think about what this means for a minute. Even though the abstract class won't ever be instantiated, a constructor we declared on it must be called by every subclass constructor. This means we're forcing subclasses to also use this constructor. Are you starting to get a picture of the abstract class as a much stricter parent? The abstract class can make subclasses follow its rules. Truthfully, any parent can, but an abstract class never gets instantiated, so you have more freedom in building the rules on this kind of class, and well-behaved classes are a good idea. Before this video gets too long, I'll stop here and pick up where we left off in the next video. In that upcoming video, I'll be implementing these concrete methods on the dog class. I'll see you in that next video.